All right, this video is going to go over 13.2 and 3a, which is exponential functions and how to graph them. So let's go ahead and get started. The first thing I would say that you need to know is you're going to have a base with an exponent, okay? B. So like over here to the right, generally it has the parentheses around it, but not always, okay? Now the number that the base is super important because if it's greater than 1, b greater than 1, it's going to be growth, and your graph is going to take this shape. All right, now if b is less than 1, it's decay, and your graph is going to take this shape. All right, so it's very helpful to know like what the shape that you're going to need to be drawing is going into the problem. All right, so like this one is growth, so it's going to be looking like this. Now, I will also say I'm not the biggest fan of doing an XY table for all of these problems, so I probably won't do that. We can do it for the first one though. So if you plug in like -1, 0, 1, 2, to get these y values, I'm just plugging, not to there, I'm plugging in x values. So this first one's like 2 to the -1, which is 1/2, or 0.5. Now, if you plug in 0, you get 2 to the 0. Anything to the 0 is 1. You plug in 1, you get 2. You plug in 2, you get 2 squared, which is 4. So this one looks like this. All right, now another very important thing to realize is exponential functions, they have asymptotes. It's a line it can't cross. It levels out at this line. So by default, this equation is y equals 0. But if you shift, like look over here, see how it shifts -4? That's shifting vertically. That's going to shift your asymptote from like 0 to -4, for example. But we'll see that more when we get over there. All right. Also, I'm not the biggest fan of finding like your HK. I find it kind of misleading, so I probably won't be doing that either. Something I think that is way more important is finding your y-intercept. And you do that by setting x equal to 0 and solving, okay? We've already covered when it's growth or decay. A value is just to stretch or compress. And I don't really care about that either. So let me just show you how I do some of these. Okay, the first thing I do is I look at the B, and I decide if this is growth or decay. So that way I know like it's going to look something like this. Okay, the next thing I do is I get my asymptote by my shift. So this one is a +3. That means my asymptote is going to be y equals 3. So my line will not cross that. And then the last thing I do is I go get my y-intercept. So your y-intercept is where x equals 0. So it'd look like this: 4 to the 0 minus 2 plus 3. Well, that's 4 to the -2 plus 3. Well, that's 1 over 4 squared plus 3. So that's actually 3 and 1/16. So it's just above this blue line right here, right? Okay, and then I just follow the pattern of what my line has to look like. It has to take this shape, and it has to hit this green dot, and it has to level out at this blue line. So it just looks something like this. And that's all I would do for it. Now, the domain of these is all reals on all of them. The range of this, the lowest it could possibly go is 3, but it can't hit 3 because there's an asymptote there. And the highest it goes is infinity. Okay. Now, this next one's a growth, but all right, let me just show you. If it was just 4 to the x, it would look like this. But the fact that they threw a negative out in front This negative is a reflection across the x-axis. So here's the x-axis. It reflects this red line across that, so it takes this shape. Hope that made sense. So this is what this one's going to look like. Now, the first thing I do is I figure out the shape, so that's done. The second thing I do is I get my asymptote. This one does not have a vertical shift, so this asymptote is at y equals 0. And then the last thing I do is I get my y-intercept by setting x equal to 0 and solving. So that's like -4. Well, it's actually negative parentheses 4 to the 0 minus 3. So that's -4 to the -3. So that's negative 1 over 4 to the 3, which is 64. So it's -1 over 64. So it's really close to 0, but it's not quite there. And then I just make my line take this shape. Remember, it can't cross this asymptote, so it could not come in like this or anything. It has to level out at that asymptote and then take the shape like this. Now, I just said the domain's all reals on these. The range, the lowest this goes is -infinity, and the highest it goes is 0. And it does not hit 0 because of that asymptote. All right, this next one. The first thing I do is I figure out the shape. This is a 2 to the x, so it's an exponential growth. So it's going to look like this. The next thing I do is I get my asymptote, which is -4. So y equals -4 here. Y equals -4. All right, and then the last thing I do is I get my y-intercept by plugging in 0 for x. So it's like 3 times 2 to the 0 minus 4. Well, that's 2 to the 0 is 1. So it's really like 3 times 1 minus 4. So that's 3 minus 4, which is -1. So here's my y-intercept. And then I just make it take this shape. Remember, it has to level out at the asymptote. It has to hit that green dot, and then it has to take that shape. So that's how I would have done that one. Okay, the next one. It has a negative out in front, so it's just like the one above it, where it's going to look something like this. Now, I know what the shape is going to look like. It must look like this. Now I go look at the asymptote. There is no vertical shift, so the asymptote is still on y equals 0. And then I go get my y-intercept by plugging in 0 for x. So that's like negative parentheses 3 to the 0. Well, that's like negative 3 to the 0 is 1. So this turns into -1. And then I just make my graph take that shape. So it looks something like this. Domain, I missed domain and range of this other one. We'll go back. Domain of this one, though, is all reals, and the range, the lowest it goes is -infinity, and the highest it goes is the asymptote of 0. Now going back, number 3, the domain is all reals because it goes left forever, right forever, and the range, the lowest it goes is -4, and the highest it goes is infinity, and you don't actually hit -4 because it's an asymptote. Okay, now this next one is these next two actually are b values that are less than 1. And so these are exponential decay problems. So if you remember, exponential decay problems look like this. They still level out at the asymptote and everything. So now that I know the shape of these are going to have to look like this. Go get your asymptote. This one has +1, so that's y equals 1, so that's here. Go get your y-intercept by plugging in 0 for x here, so that's like 1/2 to the 0 plus 1. Well, 1/2 to the 0 is 1. So you get a y-intercept of 2. And then it just has to take this shape. So it comes from like over here somewhere, and it hits that 2, and then it levels out on that blue asymptote there. Now your domain is still all reals because it goes left forever, right forever. Your range, the lowest it could possibly go is 1. The highest it could go is infinity. Which brings us to the last problem here. I know what shape it's going to take because it's an exponential decay. So I know it's going to resemble this. I go get my asymptote, which is at -4. Go get your y-intercept by plugging in 0 for x. So that's like 3 times 1/4 to the 0 minus 4. Well, 1/4 to the 0 is 1. So this is like 3 times 1 minus 4, which is 3 minus 4, which is -1. So that's here. And then just make it take this shape. So it's going to look something like this. It's going to come from up here. It's going to have to hit that green dot, and then it's going to level out at your asymptote. So if your teacher's looking for an XY table on all of these, I can't really help you that much. I don't do it that way. I just look for 3 main things: shape, asymptote, and y-intercept. So hope this video helped.